All right, let's take a look at some more questions. From the review, here's number 9. We're asked to find x-intercept, y-intercept, and the asymptotes of this rational function. So, we'll start with the vertical asymptote. The vertical asymptote is whatever would make the denominator equal 0. So, of course, -1 would make the denominator equal 0. And that's an x equals equation. X equals -1. So whatever would make the denominator equal 0. The horizontal asymptote. There are 3 rules for the horizontal asymptote, but to save time, let's just consider the rule that we have. Here, the degrees are the same. And when the degrees are the same, it's just the coefficient of the x over the coefficient of this x. And this is just an implied 1. So the horizontal asymptote is a y equals equation, and it's just that. 2 over 1, which is just 2. So for the x-intercept, if we were on the x-axis, y is equal to 0, and you know f of x is just the same as y. And if we're on the y-axis, then x equals 0. So we'll start with the y-intercept. So for the y-intercept, we have y equals, and then we replace the x's with zeros. Now maybe you just spot that it's going to be -6 because it's just -6 over 1. Because as we plug in zeros, we just zero out the term. So 2 times 0 goes away, so does that 0. Oh, sorry, this is a fraction. And so y equals -6 over 1, which is just -6. So intercepts should be ordered pairs, so 0, -6. And then for the x-intercept, we will change y to 0. So now we're just solving for x plus 1. So we can multiply both sides by the denominator. 0 times anything goes away. So 0 equals 2x minus 6. Add 6 to both sides and divide by 2. So our x-intercept is 3 as an ordered pair, 3, 0. And so you can also graph this. So put your numerator and denominator in parentheses, 2x minus 6, x plus 1. Hit graph. And we can see the x-intercept is at 3. We can see that the y-intercept, maybe it's hard to see, but you can go to the table and we'll find 0, -6 is the y-intercept. 3, 0 is the x-intercept. So again, if you know this, you can just graph it and look at the table. And so let's move on to the domain questions. The domain, so like 24 through 31 on the review. The domain for any absolute value graph makes the V shape, and so the domain is, there are no restrictions. The domain is negative infinity to positive infinity. Same thing with any quadratic. If there's a x squared, it makes a U shape, and that also has a domain from negative to positive infinity. So here are the domain restrictions. Natural log is the same as a log. So you cannot take a log of 0. If you did log of 0 in the calculator, you'd get an error. So x has to be greater than, but not equal to 0, if that notation helps. Whoops, not equal to. But here, x can be equal to 0. For a radical, for a square root, the square root of 0 is 0. It's not an error. But the square root of anything negative, you'll remember that we get imaginary solutions. And then down here, it's just that the denominator cannot equal 0. So we'll start with 31. So 1 over x minus 5 means that x cannot equal positive 5. 5 minus 5 is 0. So the domain is everything but 5. So we need to write it as negative infinity to 5 parentheses unioned with 5 to infinity. And so that's how you have to write it. If x cannot equal 5, then it goes from negative infinity to 5, and the parenthesis shows that 5 is not included, and then it picks back up and goes from 5 to infinity. So you need the two 5s, you need the unioned symbol. So here on 28, x minus 5 has to be greater than 0. Or equal to 0, because the square root of 0 is just 0, and that's fine. But the natural log of 0 is an error. So x can be equal to, on 28, positive 5. X can equal 5. So the domain starts with a bracket, 5 to infinity. Just to work that out a bit more in case anyone was confused. Again, the square root of x minus 5 needs to be greater than or equal to 0. Or what's inside of it needs to be. So if you add 5 to both sides, then x is everything greater than or equal to 5. And the line under the symbol means that it needs to go from 5 to infinity. 5 to positive infinity. For number, let's say 26, we have the natural log of x minus 4. So here, this cannot equal 0. It has to be, the piece that's inside has to be greater than 0. add 4 to both sides, and x is everything greater than 4, but not including 4. So that's the difference between the log and the square root. So this would be parentheses 4 to infinity. So make sure that you know the square root domain starts with a bracket and then goes to infinity. This is the value that you solve for. And for the natural log, so the natural log of whatever, x plus or minus, we don't know, it's going to be on the test. This domain will go from your value to infinity, but with a parenthesis. Next, this next one is one of the tougher problems on the test. We'll look at problem 36. This was frequently missed on the exam. I talked about this a lot in class, but let's look at it here. How long will it take $5,000 to grow into $12,000 if it is invested at 7.2% compounded continuously? So you'll see the word continuously, which means we use this formula. The amount equals the principal times E to the power of R times T. So I want to make a couple things clear. Some students thought that it was that E was like a base, and then it was R and T being multiplied. That's not the case. E is the base when we do a natural log, so I understand that confusion. But here, E is a value. It's just like pi. It's a constant. How they discovered it really isn't important right now. But E is a value. A, P, R, and T are all variables. So A is going to be the bigger number. P is the amount that we invest. You can think about it as the smaller amount. For the rate, here our rate is 7.2%. Don't get the rate wrong. Some students did on the test. Either divide it by 100 or move the decimal back twice. If we move it back twice, we create a gap. We fill it with a 0. Or 7.2 divided by 100 is 0.072. So that's the rate that we will plug in, 0.072. T is the variable that we are solving for. Solve for T. So we know A, we know P, E is just a value, and we know R. The one thing we don't know is T, and T is trapped in the exponent. Again, R and T are the exponent on just E. So we have to take the log of both sides. And you need to know this, that when you get the natural log of E, again, there's an implied base of E. And when the base and what you're taking the log of are the same thing, it's just equal to 1. So it cancels out. Like a multiplier of 1. So, like a coefficient of 1, it just goes away. And so when we get to the natural log of both sides, we'll find ln of E, and we'll just cancel that out. So let's get started. On problem 36, how long will it take 5,000 to grow into 12,000? So 12,000 is our amount, the bigger number. 5,000 is what we invest, the smaller number, times E, which is a constant. And it's invested at 7.2%, which is anytime you plug a percent into a formula, you have to plug it in as the decimal. And T is time in years, so the answer is going to be in years. So T is what we are solving for. And the only way to solve for it is to take the log of both sides. But for now, this is a coefficient. The 5,000 is just being multiplied times E, which has an exponent. So we can get rid of a coefficient by dividing it out of both sides. Now this should come out pretty evenly. 12,000 divided by 5,000. That's pretty good. 2.4. We'll need to use the calculator on this one. So now we have 2.4 equals E to the power of 0.072 t. It's now time to take the log of both sides. In this case, the natural log because of E. And in class, I talked a lot about expanding and condensing our logarithms. And as we do so, the exponent becomes a coefficient. So we take the natural log of 2.4, which is a value we would have to put in the calculator. And then we have 0.072 t natural log of E. So when we take the log, the exponent becomes the coefficient of the log, and we're taking the natural log of E, which cancels out. So all we need to do, but we have to use the calculator, is divide this value, the natural log of 2.4, by 0.072. And so natural log is down here, ln. Natural log of 2.4. You could leave it in as the natural log of 12,000 divided by 5,000, but 2.4 is pretty nice. And now I need to divide that value. I could hit enter or I could hit divide. I'll just hit divide by 0.072. And we get about 12 years. So T is approximately 12 years. I'm just going to check our work by plugging in 12. So we're not going to get exactly the 15 or the 12,000. But let's take a look. Our formula on the right side is 5,000. And second natural log brings up E to a power, and I'm going to type in 0.072 times 12. And we get a little far away from 12,000. Let me check myself. I'll do natural log of 2.4 divided by 0.072. And then I'll do 5,000 e to the power of 0.072 times the previous answer. All right. So there it is. If you use the exact answer, you'll get exactly 12,000. This was far enough away that I thought something had gone wrong. But t is approximately 12. It takes about 12 years. We'll look at 40. 40 is a fun one. We have a radical on one side, a square root of x plus 3, equals x minus 3, which is a binomial. So, on problem 40, oh boy, we have the square root of x plus 3 equals x minus 3, which I just kind of naturally put in parentheses. But as we square both sides, squaring a square root, that goes away, and now the x plus 3 is just by itself. But here, think about your binomial as having parentheses around it because we need to square the binomial. You can't just square the x and just square the 3. As I said early in the course, a binomial squared means you write it twice and FOIL it out. X times x is x squared. On the outside and the inside, we get the same negative 3x. And then negative 3 times negative 3 is positive 9. And let's simplify our middle terms. Negative 3x minus 3x is negative 6x plus 9. And now we get everything on one side because to solve a quadratic we have to be equal to 0. I'll do this in the same step. We're just subtracting 3 from the 9 over here. So we subtracted the x, we subtracted the 3. We cleared out the left side, so we're set equal to 0. And we just combine like terms. And this factors into x minus 6 times x minus 1. And we set each factor containing a variable equal to 0. So we get solutions, possible solutions, of x equals 6 and x equals 1. Now, checking is always a good idea, but in a square root equation, you must check. So, we need to go to the original equation, square root of x plus 3 equals x minus 3, and plug in both solutions. So let's check 6. 6 plus 3 equals 6 minus 3. So on the left side, we're under a radical. The square root of the square root of 6 plus 3 is the square root of 9. 6 minus 3 is 3. And the square root of 9 is 3. So this checks out. The way it's going to work is you'll get one, like 3 equals 3. And then you'll get another that's going to be 3 equals negative 3. And that's not going to be the same. So let's plug in 1. The square root of 1 plus 3. So I'm just going back to the original. Replace this x with 1. 1 minus 3 is negative 2. You can actually stop right here. A square root cannot equal a negative number. Even if it's the square root of a negative, it would equal an imaginary number. So this is where you get, the square root of 4. 1 plus 3 is 4, and then the square root of 4 is 2. 2 does not equal negative 2. So you have to reject what brought us here, which was 1. So we reject 1 as a solution. The only answer is, that's not the answer, that was how we checked. The only answer is the x equals 6. I'll do one more. 44. .44 is pretty easy. You're not going to get a quadratic or anything. And these are a lot more difficult if the denominators do not match, but here they match. So the hardest part of this problem is distributing x minus 2 to 4. So we have an LCD, a least common denominator, of x minus 2. It's the only denominator. And so to get rid of a denominator, you multiply both sides by the denominator. I'm sorry, not both sides, you multiply everything by the denominator. And when you multiply the 4 times x minus 2, you have to distribute. So, for the first and third terms, as you multiply by the denominators go away. And now we just have the 2 over there. And then we have plus 4 times x minus 2, which is 4x. 4 times negative 2 is negative 8. And this equals just the x. So now we're just solving a basic equation. We have a 2 and a negative 8 on the left side. So we just combine 2 minus 8. 2 minus 8 is negative 6. So negative 6 plus 4x equals x. Here, I don't know what y'all would do. Maybe you add the 6, and then you can just subtract the x. So 3x equals 6. Divide both sides by 3, so that x equals 2. But oh wait, isn't this interesting? If we go back to the original problem, as we work it out, we get a solution of 2. But just like the square root equations, you can get false answers. Here, if we plugged in 2, what would be in the denominator? 2 minus 2. And that would be 0, which x could not equal. So from the beginning, we know that x cannot equal 2, which is how you should start the problem, by identifying what x cannot equal. So that's where you start. Identify what x cannot equal, what would make the denominator 0. And if you get that as the answer, then there is no solution, which could look like this, like an empty set. Nothing, like the braces with nothing inside of it. Or it might say no solution. Can't remember. Don't have the version of the test in front of me. Yeah, I'll stop this video here and record the next one.